Okay, the next reaction that we're going to learn how to predict is the single replacement reaction. Now this is found on page 194, but you're also going to need this thing called the activity series for single replacement that looks like this, and that is located in page 12 of your notes. Okay, so let's think here for a second. You're going to need this activity series to determine if a reaction will take place or not. So if we remember, with the single replacement reactant, you have an element plus an ionic compound or water, and you kick out the less attractive element. So with that being said, we have to figure out if the element that is trying to get in on this compound is more attractive or not, okay? And this is what this series is going to tell us. So let's look at a couple of these examples. So if the element is higher up, that means that it's more attractive and it will always replace the element that's below it. So if we take a second to look at this activity series, okay, so these are very active metals, where these are less active metals down here. Okay, now if I look at this, we see hydrogen right here in this little list here. Because you remember, hydrogen will be in water, which is where we can react metals with water to see if they'll get kicked out. Now you'll also notice that gold, platinum, and silver are at the bottom, right? And this is why the metals that we make jewelry out of are made out of these things, because they're not reactive, right? I would hate to be washing my hands and form hydrogen gas because my ring is very reactive with the water that I'm washing my hands with. And this is also why some of your rings will change your finger green if they're not gold, platinum, or silver. Okay, so let's look at how some of these reactions go. So think of a competition here. So the boys will not match with the boys, okay? So metals will not end up with metals. All right, so let's look at an example here. So lithium is my metal, silver is my metal. So I have to look on my activity series here. And lithium is all the way up at the top. So silver is not going to win here. So silver is more attractive. So what happens is lithium comes in and kicks silver out. Okay, now this is important. If I have a Hofbrinkel, I have to make sure that I make it as an H, or as its diatomic. But in this case, I just have metal, so it's not going to be a Hofbrinkel. So it's going to be silver. And then I have to make sure that I write lithium chloride right. So lithium is +1, chlorine is -1, the charges cancel, therefore this will be LiCl, lithium chloride. Okay, so with that being said, if I react silver with lithium chloride, this reaction will not happen, right? Lithium is more attractive than silver. So in this reaction, I'm just going to write no reaction. It's not going to happen. No reaction will occur. Okay, now let's look at the next example here, okay? I have sodium chloride and fluorine. Now, if I look at my activities chart, I realize fluorine is not in competition with sodium, because if I look down here, the activity of the halogen nonmetals, okay, I have to compare fluorine with chlorine. And in this case, fluorine is more attractive than chlorine, so fluorine will come in, kick chlorine out, and then chlorine will be by itself, okay? So fluorine will come in, kick chlorine out. So then I'll have fluorine, which is Cl2 because it is a Hofbrinkel, and then I'll have sodium fluoride. Now, here's the thing. Sodium is +1, fluorine is -1, so the charges cancel. So then I get sodium fluoride, but then I have to balance, right? Because I have a 2 here and a 2 here. So I'm going to balance the chlorine, and I'm going to balance the fluorine, and then I'm good. Okay, let's look at one or more of those examples. So I have iodine in competition with bromine. Okay, iodine is lower than bromine, so this is going to be no reaction. Okay, this does not work. Okay, now, what if I'm reacting water with a metal? Okay, think of water as OH here. Okay, meaning the metal is going to become a metal hydroxide, and then you're going to be making a hydrogen gas, which is H2, because it's a Hofbrinkel, okay? So let's look at an example here. So I have potassium plus hydrogen in water, because this is H2O, okay? So let's look here. So I'm comparing potassium and hydrogen, okay? Hydrogen is all the way down here. Potassium is up here. So potassium is more attractive, so it's going to come in and kick the hydrogen out. Okay, so it comes in, kicks hydrogen out. I'm going to make H2 because it's hydrogen gas, not H because that doesn't exist. But then I'm attaching the potassium to the hydroxide. Hydroxide is -1 and potassium is +1. So charges cancel. So this is KOH. And then the last thing I have to do is balance. Now these are some of those where we have an odd number of oxygen. So I have to put a 2 here to make 4 hydrogens on this side. And then I can put a 2 here and a 2 here to make everything else balanced. Okay, I'm going to do these 2 more examples here. So again, I'm thinking of water as HOH like this. However, we know that silver is not more reactive than hydrogen, so this is going to be no reaction takes place. Okay, now we have hydrogen attached to the nitrate. Okay, so let's look at calcium and hydrogen. Calcium is more attractive than hydrogen, so calcium is going to come in and kick hydrogen out. So I'm going to have H2 plus, calcium is +2, nitrate is -1. So it's going to be CaNO3, 2. And then I have to balance. So I'm going to put a 2 here. And I should be good, and I am. Okay? Let's do a couple more examples. So I have zinc, and it's telling me that it's +2, even though you should know that because it's an always. So I have zinc metal placed in a solution of barium acetate, and it gives you that formula too. So barium acetate is CH3COO2. Okay, so I'm comparing zinc and barium. So let's see here. Zinc is here, barium is here. So this is going to be a no reaction. Okay, and then the last one, it says tin is placed in a concentrated solution of hydrochloric acid. So I have tin plus HCl. Let's see if a reaction takes place. So tin is more reactive than hydrogen. Okay, so we're going to say tin is +4 here. Okay, so tin comes in, kicks out HCl. So I have H2, and then I'm going to have tin chloride, and I'm going to have a 4 here. So I'm going to put a 4 here and a 2 here, and then I'm balanced. Okay, so hopefully this makes sense. If not, watch the video again, ask me questions, and we'll go over them in class. Thank you.